Introduction. See those holes on honeycomb?
Yeah, how beautifully the bees make honeycomb.
Have you noticed the holes in that? They're in pattern.
Hey, yes, they form a pattern.
In nature we can find so many things with patterns.
Things like,
Things like pine cone.
wow, I never noticed this pattern before.
Our maths teacher taught us about one of these patterns in which succeeding terms are obtained by adding a fixed number to the preceding terms.
That sounds interesting. I also want to know about such type of patterns.
Okay, I'll tell you more about it. Objectives. At the end of this lesson, you'll be able to explain arithmetic progression, define term and common difference, write the general form of AP, find the nth term of given AP, find the sum of first n terms of the given AP, and solve definitions 1. In nature, many things follow a certain pattern, such as the seeds of a sunflower, the spirals on a pineapple, the pattern on cactus, and so on. Arithmetic progression is a study of one of such patterns. The arithmetic progression can also be called as arithmetic sequence. Before talking about arithmetic sequence, let us know what a sequence is. A sequence is a set of numbers that follow a pattern. We call each number in the sequence a term. Look at this example of sequence. This is the first term. This is the second. This is the third, and so on. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. This fixed number is called the common difference of the AP. Look at this sequence. We can see here that the common difference is 3. In general, we can write an arithmetic sequence like this: A plus D, A plus 2D, A plus 3D, and so on. Definitions 2. Look at this example now. We can see that this sequence has a difference of 3 between each number. Therefore, A is equal to 1, the first term, and D is equal to 3, the common difference between terms. Let's form the sequence using A and D. We know AP is equal to A plus D, A plus 2D, A plus 3D, and so on. Substituting the value of A and D, we get 1, 1 plus 3, 1 plus 2 into 3, 1 plus 3 into 3, and so on, which gives the sequence 1, 4, 7, 10, and so on. There are two types of arithmetic progression: finite arithmetic progression and infinite arithmetic progression. The arithmetic progression having a finite number of terms, or which has a last term, is called finite arithmetic progression. And arithmetic progression having infinite number of terms, or which does not have a last term, is called infinite arithmetic progression. Here are some examples of infinite arithmetic progressions. Look at this sequence now. Can you tell its common difference? Yes, you're right. Its common difference is minus 3. In general, for an AP, A1, A2, and so on till AN, we have D as AK plus 1 minus AK. Example. Let us now solve some examples. Observe this sequence. We will find out whether these numbers form AP or not. Here A1 is minus 3, A2 is 3, A3 is minus 3, and so on. Now let's find A2 minus A1, which is equal to 3 minus minus 3, which is equal to 3 plus 3, which is 6. Also, A3 minus A2 is equal to minus 3 minus 3, which is minus 6, as A2 minus A1 is not equal to A3 minus A2. The nth term of an AP. If the initial term of an arithmetic progression is A1 and the common difference of successive numbers is D, then the nth term of the sequence is given by an is equal to a1 plus n minus 1 into d. We know that an is also called the general term of the AP. If there are m terms in the AP, then am represents the last term, which is sometimes also denoted by L. Now by using the formula of nth term, let's find the 8th term of the given AP. Here a is equal to 2, d is equal to 7 minus 2, which is 5, and n is equal to 8. We know that an is equal to a plus n minus 1 d. So, a8 is equal to 2 plus 8 minus 1 into 5, which is equal to 2 plus 35, which equals 37. Example. Determine the AP whose 4th term is 6 and the 7th term is 9. Solution. It's given that A4 is 6 and A7 is 9. Therefore, A4 is equal to A plus 4 minus 1D, which is equal to A plus 3D, which equals 6. Mark it as equation 1. And A7 is equal to A plus 7 minus 1D, which is equal to A plus 6D, which equals 9. Mark it as equation 2. Now solving the pair of linear equations 1 and 2, we get A is equal to 3 and D is equal to 1. Sum of first n terms of AP. We know that the nth term of AP is an is equal to a1 plus n minus 1 d. Let S denote the sum of the first n terms of the AP. Therefore, we have S is equal to a plus d plus a plus 2d plus so on plus a plus n minus 1 d. Mark it as equation 1. Now we will rewrite these terms in reverse order. So we get S is equal to a plus n minus 1 d plus a plus n minus 2 d plus so on plus a plus d plus a. Mark it as equation 2. Now by adding equation 1 and 2, we get S is equal to n upon 2 into 2a plus n minus 1 into d. This is the sum of first n terms of AP. This can also be written as, we know that a plus n minus 1 d is an. So S becomes n upon 2 into a plus an. We can also write the last term an as L. Therefore, S becomes n upon 2 into a plus L.